Today we're going to be extending our study of systems, and we're going to move on to inequalities. So today is the basic of linear inequalities. And I want you to notice about inequalities, like when I told you something like x is greater than 5, you said, oh, x might be 5.1, it could be 6, it could be 3 million. You remember that had an infinite number of solutions. So I want to extend that idea today. Okay, so we're going to focus on graphing linear inequalities to show all these solutions because it's impossible to list them all. The first thing I want you to do when I ask you to graph a linear inequality is to graph the boundary equation. So for example, if the inequality says y is less than 2x minus 3, the first thing that you would do is graph y equals 2x minus 3. Okay, the boundary equation. If the inequality symbol is less than or greater than, then you use a dotted or a dashed line. If the symbol is a less than or equal to or a greater than or equal to, the line is solid. So if I were graphing that y equals 2x minus 3, I'm just going to give you a little sketch here. But I would start out at -3, the y-intercept, and I'd use the slope up 2 over 1, up 2 over 1, and I'd say, oh, it's a less than sign, so I'm going to make a dotted line, not a solid line, a dotted line. Okay? And the next thing you do is test a point that's not on the boundary. So the boundary is that line that you drew. That's going to be the boundary of what's going to work for the equation or the inequality. And so you test it to see if it makes the inequality true. If 0, 0 is not on the line, I like to use 0, 0 because it's kind of easy. X and y are both 0 and it's not a lot of computation. So if I go back to this original inequality that I used here, y is less than 2x minus 3, I would plug in 0 is less than 2 times 0 minus 3. 0 is less than -3. That's not true. What that means is this point in 0, 0 is not a solution, okay? So what I might want to do to be safe is try a point that's over here, like maybe I'll try 5, -5 or something like that. So 5, -5 could be, -5 would be y, -5 is less than 2 times 5 minus 3. -5 is less than 10 minus 3 is 7. -5 is less than 7, so that is true. So this equation makes it true, or this point, 5, -5. So what you're going to do, the last thing, is you're going to shade the half plane that makes the inequality true. What will work, as long as you've done all your computation right, is if one point on the region of the line, below or above it, works, every point on that should work. So we're going to shade it and say everything over here on this side of the line is a solution. Okay, so here's our step to graphing inequalities. All right, let's look at this one. Y is greater than -2x plus 1. So it would be awesome if you could try to do this one on your own. But if not, if you still need to work along with me, I know we've only done one problem. So we're going to start it by graphing y equals -2x plus 1. So I've got my y-intercept on my graph. That's at 1. I'm going to rise then run on my graph. So down 2 over 1, down 2 over 1, down 2 over 1. And I'm going to go ahead and fill up this whole plane because that's going to make it a little bit easier. Okay, and then it's a greater than, so it does not have an or equal to. I'm going to give it a dot line. What that means is that points on that line are not actually part of the solution, just like how when we did an open circle before. Okay, so y is greater than -2x plus 1. So now I can try a point like 0, 0 again. 0, 0 looks like it's below the line this time. So I want to know, is 0 greater than -2 times 0 plus 1? 0 is not greater than 1, so that's false. So 0, 0 should not work. Therefore, I think that all the points above the line will work. I can just make a gamble that I did my math right and shade that in, or I could actually test a point like, here's 4, 4 should work. Let's try it's 4 greater than -2 times 4 plus 1. 4 is greater than -8 plus 1. Yeah, 4 is greater than -7, so this looks good. I think I shaded the correct side. Okay, all right, let's look at another one. Graph 4x minus 3y is greater than or equal to 9. So you've got two options here. This is not in slope-intercept form. It's in standard form, so you can graph it straight from standard form if you're comfortable with that. Remember, we could be graphing 4x minus 3y equals 9. So you remember that for the x-intercept, y would be equal to 0, so we could kind of get rid of this part right here and just look at 4x equals 9. So the x-intercept looks like it's going to be 2.25, 9 divided by 4. And the y-intercept, I would get rid of the 4x and it would be negative 3y equals 9. So the y-intercept would be negative 3. So that's one way I could do it, is just graph those. So the y-intercept's negative 3, the x-intercept's 2.25. And if I look here as a greater than or equal to sign, so I'm actually going to draw a solid line this time. Okay, and then I'm going to shade the half plane that makes it true. So if I put in x and y both for 0, 4 times 0 minus 3 times 0 is greater than or equal to 9. 0 is greater than or equal to 9. Again, that's false, so it's going to be the other side that does not have 0, 0 on it, which in this case is below. Okay, so these would be all the solutions that would make that true. Okay, now if you don't like graphing from standard form, you can graph from slope-intercept form. You'll just want to be cautious here. So when you do 4x minus 3y is greater than or equal to 9, you could subtract 4x from both sides. And then we have negative 3y is greater than or equal to negative 4x plus 9. And if I divide both sides by negative 3 in this case, then I have y. Now remember, I divided both sides by a negative, so don't forget that I need to switch that symbol. Y is less than or equal to 4/3 x minus 3. So if I graph that, I'm going to start at negative 3, go up 4, 1, 2, 3, 4 over 3, 1, 2, 3, which is exactly the same as the line that I already have. So that's good. And I would shade underneath it. Okay, let's look at a word problem. At least if I can get it to react. Okay, here we go. Suppose your budget allows you to spend no more than $24 for decorations for a party. Streamers cost $2 a roll and tablecloths cost $6 each. I want you to use intercepts, okay, so the idea of the x and y intercept, to graph the inequality that represents the situation. And then I want you to find 3 possible combinations of streamers and tablecloths you could buy for this party. So first we need to figure out our variables. I'm going to call x my rolls of streamers, and I'm going to call y my number of tablecloths, because these are the 2 things I'm wanting to buy. And then when I do that, I'm going to set up an inequality. So I know that streamers cost $2 a roll, so it's going to cost me 2 times x for my streamers. Tablecloths cost $6 each, so 6 times y for my tablecloths, and I would add those together, and altogether I can spend no more than $24, so that's less than or equal to $24. All right, I am going to try to use intercepts for this method. So my x-intercept, that would look like 2x equals 24, so my x would be 12, and my y would look like 6y equals 24, so my y would be 4. Okay, and then I'm going to go ahead and graph this. Obviously, we're doing streamers and tablecloths, so we aren't going to have negative values, so I can just make a 1-quadrant graph. Let's just get these labeled. So I'm going to call this x, I said that was streamers, and y, I said was tablecloths. Oops. So I need to get right out of there. Cloths. I'm going to count by ones here. So 1, 2, 3, 4. And I'm going to go by ones again, but I'll just mark every other one. 2, 4, 6, 8, 10, 12. Okay. So what I know is I already know my x and y intercepts. So my x-intercept's at 12, and my y-intercept's at 4, and then I'm going to draw a line between those. Let's see if I can get this somewhat straight. Okay, there we go. And it's solid because I can do less than or equal to 24. Okay, and if I plug in like the point 0, 0 again, 0 plus 0 is less than or equal to 24. So it looks like the part that's going to be shaded, and I'll shade in a light color this time, is down here. Okay, but I don't need to go into the negatives because I don't have any negative values that I could buy. Okay, so the question then asks, find 3 possible combinations of streamers and tablecloths you can buy. So what we're looking for is anything that's on the line or in the yellow area. That would be a solution. So we just want to kind of check and see. So it looks like here I could buy, hopefully, that point right there, 2 streamers and 3 tablecloths. And if you're not sure, you can actually check that and see if it works. So 2 streamers, that would be at $2 each would be $4. And then 3 tablecloths at $6 each, that'd be 18. 4 plus 8 is 22. That works. It's underneath 24. And you can make it exactly. So that's one combination. And then you can look for any others that you're pretty sure are either on the line or right in there. Okay, I could also do like 3, 3. That's right on the line. 3 streamers, 3 tablecloths. Or maybe I would do like 6, 2, a little bit underneath the line. 6 streamers, 2 tablecloths. There's a lot of right answers here, as you can see. But you need 3 combinations of stuff that you could work. I mean, maybe you'll say 4 tablecloths and no streamers, but if you want, I'd like you to probably get a combination of each. Okay, so here's what I want you to think about at the end. How is graphing linear inequalities similar to graphing linear equations? So what's the same about those two things, and then what's different about those? All right, think about that, wrap it up, and we'll see you guys later.